Welcome back to Kredict. We are in day 4 of 45-day challenge in learning blockchain development, and you are with Kredict. In previous videos, we have seen how we can install MetaMask wallet, set up our first account, what is Remix IDE, and in just previous video, we have written and deployed our first smart contract. And today we are going to explore further about smart contracts and writing smart contracts. So without wasting any time, let's get started. So I'm going to open my browser. If you are new to this challenge, I highly recommend you to watch previous videos first, then come back to this and continue after. Now we are going to open our Remix IDE, and let me quickly open this from my bookmarks. Our Remix IDE is now open, and here is our folder blockchain tude, in which we have created our first smart contract, and the name of smart contract is also first contract. If you remember, we have created the smart contract and deployed it, which has 2 variables and 4 functions. 2 functions for updating those variables and 2 functions for getting the value of those variables. Let me quickly revise you this stuff. For now, I'm going to close this. So here it is, Pragma Solidity version 0.8.20. This means this file can work on versions 0.8.20 and later. This is the line which specifies the body of contract and the name. So the name of contract is first contract, and in this curly braces, if you can see these yellow curly braces, this is the body of smart contract. Inside this smart contract, we have 2 variables, string name and string name 2. These are of string data types. And we have a function set name, which takes a parameter new name and set it to the variable name. And we have similar this get name, which returns the name of first variable name. And these 2 functions are similar for updating the value of second variable. So today we are going to modify this contract to do different type of stuff. So let's get started. If you notice, we have created a function to set value, but also we have created a function to get value. But in Solidity, if you specify any variable with public scope, then it does not require any separate function for creating getter methods. What does it mean? Let me show you. So for now, I'm just going to remove all these 4 functions and this second variable also. So now we have only one variable of string name. If you remember, to get this value, if you want to get this value, we have created a function says get name. But here's the interesting part. If you specify this variable as public, then the Solidity automatically creates a getter function for it. What does it mean? Let me show you. I'm going to create only set function for this. Set name, which takes a parameter of string, new name, and it's a public function if you remember, and it returns nothing, so we'll not write anything in the return clause. The body of function, and we set name to new name. So this is our setter function, and now we are going to deploy this contract without specifying any getter function, or let's see what happens. So I have to set my compiler, it's by default on 0.8.24. Go to this tab, deploy and run transactions. By default is the account selected. I'm going with this. Select your smart contract and click on deploy. So here you can see we have only created the function set name, but here is two functions available. One, the set name we have designed, but second says name, which is same as the name of this variable. So when we have declared it as public, Solidity automatically creates a getter function for it. So let's see this in action. Let me type a name here, Travis John, and set name. And now when I click on this name function, it should return the value stored in name variable. So I've set it the name and it returns the name. So here we have learned a new thing. If we define any variable in Solidity with public keyword, it will automatically create a getter function for it. So now you know we don't have to explicitly specify the getter function for this variable. And we want to replicate our previous example, we can also do this. Just write string public name 2. Notice we have also specified it as public. Write second function set name 2 string memory and new name 2. This function is also public scope, which means anyone can access this function on the blockchain, but this is a virtual blockchain, so nobody is going to see or execute this function. But this is when you deploy on public blockchains like Binance Smart Chain, Ethereum, then anybody can execute these functions, which is specified with public keyword. So let me write here name 2 equal to, or assign, we assign name 2 to name new name 2. So we have completed our contract, and if you don't want, you can remove this also. So I'm going to remove the previous contract because we cannot modify the deployed contract, so we have to redeploy it. So let me quickly click on deploy, open this, and now you can see here are two set functions and two get functions. Let's type John for name 1 and Travis for name 2. And now when we click on name, it will return the first name, and we click on name 2, it will return the name 2. So here is our previous example, but with a different approach. In this, we have not created any getter function to getting these values, but we have just declared those variables as public, which means they can be accessed by anyone, so it does not require any getter function explicitly. Now if you are confused with what is get and what is set, or what is getter and what is setter functions, let me clear you. Setter functions are those functions which are used to set values for any variable, and getter functions are those functions that used to fetch or return those variables values. That's why it's called getter and setter functions. If you are coming from object-oriented programming like Java, you may already have idea about this concept. Okay. Now we have already seen this public keyword many times. We have public here, we have public here. So what is this public? As the name suggests, it's a scope definition for these variables and functions which declares that this function or variable can be accessed from anywhere on the blockchain, which means anyone can access these functions. We have other types of scope specifier also, like we can write external here. So now what is the difference between public and external? Let me quickly write it here. Public scope can be accessed from outside or inside. Outside from smart contract or inside from smart contract, which means if this function has public, this function can also call this function. So I can call this like name2 and also specify new name to this. So we have public function, so we can call this from internal or externally, which means anyone can call this function from inside or outside. But in case of external specified functions, it can only be called from outside the smart contract. Outside the smart contract. So if I try to call this function internally, let me show you. So here you can see our compiler gives an error. Let's quickly check it. Click on this icon. And here you can see undeclared identifier. Did you mean set name2 or set name? Which means this variable or function is not accessible in the scope. That's why it specify it as undeclared identifier. So if we specify it as public, the problem will solve. Let's quickly change the order so it will work fine. So now you can see we have public functions and it can be accessed from inside or outside. The third thing is internal. The third keyword to specify scope is internal, and internal is just opposite to external, which means external functions can only be called from outside the smart contract, but internal functions can only be called from inside the smart contract. Only called from inside. So let me quickly show you. Just remove this for now. Remove this. Okay, so we have this set name and let's specify this as internal. So we have created a function with internal scope, and when you try to deploy this, let me show you. Just quickly deploy this. Open this. So you can see there is no function named set name. There's only two functions or getter functions, that is name or name2 to get values in these variables, but there is no function as set name. That's why, because we've specified it as internal, so it can only be called from inside the smart contract but not from the outside smart contract. So how to use this function? Actually, we define these types of function that we only require to execute from inside the contracts, like calculating some transactions value, taxes, percentage, commissions. These types of calculations which are not required to show to whole public, we do these type of transactions internally with internal functions. So how you can use this? Only smart contracts functions can call the internal function. Call internal, or we can pass a value here to set through this. internal name, you can say, or anything you want. Just specify it as public, or for now let's specify it as external. And you can call this function set name and pass the internal name value. So let's quickly deploy this. Just close this or deploy a new one. So here we have deployed our smart contract, and you can see we have now this call internal function, which calls the actual internal function set name and pass the given value to this function, and it will set the value of name to the provided value. Just quickly write here Travis John and transact, and if you click on name, you can see the name has been updated. So this is generally three types of scope specifiers: public, external, internal. We can use these type of scope specifier to specify the scope or a function variables also. Yes, you can specify variables with these keywords, and this works similar to that function. And any function without this is like same as internal, which means you can see if we have no specifier here, it is by default internal. So if you want to make it external or public, you have to specify it, but if you have not declared anything there, then it is internal by default. So keep this thing in mind. Now we have seen how this scope specifier work and what are these types and what exactly this do. So just quickly create another smart contract with some functions and variables and try to do some stuff. So let me quickly this and close this for now, and I'm going to create a new file. Okay, so this something wrong happened with my remix. I'm just quickly going to refresh this, reload. So it's fine now. Let me quickly create a new file like calculate values, or you can rename it as calculator or something. So actually we are now going to create a simple calculator in Solidity. Yeah, this has no use, but this can clear the basic arithmetic operations in Solidity. So just open up your editor and follow along to create this calculator with me. Now if you remember, let me quickly increase the font size here. Okay, so the first thing is we have to specify the Solidity compiler version. For this, type pragma Solidity cap 0.8.20 something. Okay, press enter, write the keyword contract and name your contract. I'm going to name this calculator. Okay, so this is my contract body and all the code related to contract goes inside it. So just quickly create some functions to do basic arithmetic operations. First of all, I'm going to create a function for addition. I'm going to write function add, which take two values of both integer types. So I'm going to write int a comma int b. This is public function, or you can say external. You can specify public or external. For now this doesn't matter, but in future I will tell you when to use public and when to use external explicitly regarding how to save gas fees with it. But for now you can write external, public, anything, doesn't matter. And this will return the answer. So we have to write returns and the type of return value is integer. Okay, this is our function which should return the arithmetic addition of these two values a and b. Let's write a plus b. So now you know why these yellow lines come, because this does not change the state of blockchain. So you can specify it as view. Let's quickly write view. Why this is still coming up? Let's check. Function state mutability can be restricted to pure. Okay, so just write pure here. And this is other thing to view. View is for like only functions that returns the values or only read the states, but the pure functions are completely different. They does not change the state. They works on the variables or parameters provided to this. So that's why we are using pure here. Okay, just close this for now. So this is our first function for addition. Just create another function for subtraction. I'm going to rename it as sub, int a, int b, external, pure. Just write same thing in above function, and it will return a minus b, the subtraction of a minus b. And I'm going to quickly copy this 2 times more to create another 2 type of function. Okay, so this is error. Just rename this to mul or multiply ab, and it returns the multiplication of a and b. And the second is div or division, you can say, ab, and it returns the. So we have now a contract named calculator, and it has 4 functions. Obviously the addition, subtraction, multiplication and division. So just test this contract now. Just deploy, and here you have 4 functions. Let's quickly open this to have a clear view. Okay, so all these 4 functions take two values and return the corresponding result to us, like addition, subtraction, multiplication and division. The first function is addition. Just write 2 and call. So you can see it returned us 4. If this is not big enough, let me quickly zoom it. Okay, so I think it's now visible here. You can see 4, which the true is 2 plus 2 is 4, obviously. So let's quickly test this division function, which comes up after addition. Just type 10 and b, I can say 2, call, and it is 5. Yeah, and the third function is multiplication, so it's going to write 4 and 5 and call, and it has returned 20, which is correct. And now the fourth function is subtraction. I'm going to write 567 and subtract 67 from it. So it has returned 500, which is true. So this is our basic smart contract for calculator you have seen. Let me quickly zoom out. Okay. Now here you can see we have 4 functions with 4 different operations. So what we have learned with this, that Solidity supports all the basic arithmetic operations similar to other programming languages, and it works exactly other languages in this state. But the main question arises about the division part, because I have told in earlier videos that Solidity does not support floating points. So if you write any value that returns floating point in division, what does it give? Let's quickly check it out. Let's write here 5 and divide it by 2. The actual answer we know is going to be 2.5, but let's see what this function returns. So I'm going to click on this call and it has returned 2. So I know this truncates the whole decimal part and only returns the integer part of the answer, which is 2. And if you write any random, you can say odd number and divide it with 2, it only returns the part before decimal point. After the decimal point, values are deleted. So this works similar to the division function in C language if you are familiar with, and if you are not, just keep in mind that division function only returns integer part. It will not return any decimal part of the answer or the result. Okay, so keep this thing in mind. Let me quickly close this. So we have this calculator. Now we are going to do some complex calculations. Now we are going to create a function for calculating parameter of a rectangle. Yeah, this is very simple, but just quickly write it to see how we can do this in Solidity. So right here, function, I'm going to name this perimeter, pass two sides like length and width. It should be external. You can write here pure, but I will show you something in just a moment. It should return int because there's nothing like float in Solidity, so it will not give exact answer, but you should have an idea to how to calculate this type of answers. So now we have to store the answer in a variable. We can return it directly, but for now we want to store this in a variable. So just quickly write int answer, and if you know the formula of parameter, it's 2 into L plus B. L plus B stands for length. We have W here, so not breadth, it's width now. Okay, so 2 into length plus width, and now I'm going to return this answer. So here we have created a function for a parameter of a rectangle, or you can say square, or any shape which has length and width or two sides similar. So just quickly test this function. I'm gonna deploy the smart contract again. Just close previous one and deploy it again. Open this, and you can see we have a new function says parameter, which takes two values, length and breadth. So just write 2 and 4 for width, call, and here it is 12, because 4 plus 2 is 6 and 6 into 2 is 12. So the answer is correct, and it has returned the perimeter of our shape. So here we have seen the basic arithmetic operations in Solidity, and you can do this all kind of stuff together. So I'm going to an interesting case to you where you have to return multiple values from the answer. For example, just quickly delete all this, and we want a single function that returns all the values. For example, we have two numbers and we want all type of arithmetic operations like addition, subtraction, deletion, and not deletion, multiplication and division. So how you can do this? Just for now delete this. Okay, so here the case is we need 4 different values, so we have to specify here which type of 4 values we are going to return from this function. So all these 4 values are int. Let's quickly write int 4 times. Just gonna format this quickly. Okay, so it's formatted, and if you're confused, just think it's like a linear. Okay, so this is the function body, and here we can store different answers like int add, we can say a plus b, int sub equal to a minus b, int I can say mul equal to, or multiplication for mul, a multiplied by b, and last is int div equal to a divided by b. And just rename this to arithmetic. I think the spelling is correct. Okay, so we have now 4 values, and if we want to return all these values, we have to use a bracket, or you can say braces, add sub mul and div, and put the semicolon here. So now what this function do, this function take 2 numbers and perform all the basic 4 arithmetic operations and returns the value in sequence. So just quickly test this, delete this older one, make sure the correct contract is selected and click on deploy. Yes, yeah, so we have a function says arithmetic. We have a single function here in our contract. Let's quickly pass some values. For simplicity, I'm just going to pass 2 and 2 and call, and you can see it has returned 4 values of int 256 type. What is int 256 and what is 256 here, I have described in previous video. If you want, you can go and check that out, but let me quickly clear this to you. They specify the size of integer. Here the integer we have used is 256-bit integer, which means it can store values up to 256 bits. Okay, so now here you can see it's returned. Let me quickly zoom it a little bit. Okay, so for first it returned us addition, which is 4, because 2 plus 2 4, and subtraction of 2 minus 2 is 0, and multiplication is 2 into 2 4, and last division 2 divided by 2 always gives 1. So you can see our functions work perfectly. Just close this. So far we have seen the specifiers for scope like public, external, internal. We have seen basic arithmetic operations. We have seen if we declare a variable with public specifier, the Solidity automatically creates a getter function for it, and we don't require to create a getter function explicitly. Okay, so this is all for today in the day 4 of 45-day challenge Learn Blockchain Development with Kredict. I hope you got all the points cleared, and if you have any doubt, just ask in comment section. We will reply and try to solve your problems. Till then, keep watching Kredict for these types of latest blockchain related videos, and I will see you in the next job challenge. Till then, stay safe.